Alrighty then, so in this video I'm going to show you a little bit about the engineering behind SolidWorks and how we could use SolidWorks parts and the assemblies that we put together and actually test them to put some forces on them, see if they're going to bend and break. So I'm going to be using what they call Simulation Express, and in the full-blown version of SolidWorks in the CAD lab you're going to have simulation. Simulation has got a lot more bells and whistles to it, it's got a lot more options, and we'll do a lot better job solving your design that you put together rather than Simulation Express. But what Simulation Express does is it allows me to give you just the basics to get started. I'm just going to show you the basics in Simulation Express. How to apply a fixture to the bottom of your part or wherever it might be, how to apply a load to a different part of your part, and apply those together and see what happens to your part, see if your part actually breaks. So we're going to use our SolidWorks mechanism over here. I'm going to go ahead and right click on our wheel mount, and we're going to test our wheel mount and see what we can do about breaking this. So let's do this. I already have a fillet in here. I'm going to take that fillet and actually delete that. So I'm going to right click on it and I'm going to delete that for now. We're going to bring that a little bit later. So what we're going to be doing with Simulation Express, and again, for your final design project, you got to do simulation. Again, it's got a lot more options. So there you have it. So let's do this. The way you find simulation or Simulation Express, where you find a simulation is you want to go up here to Tools, scroll down, you want to go to Add-ins. This is going to be one of the options over here in the selection box over here. And once you select that, you're going to get a toolbar very similar to this. An Evaluate toolbar, you can see it over here for Simulation Express. You're probably going to see it in the menu pull-down over here. And there might be other locations too where you're going to see that. But for here, I'm going to go ahead and show you Simulation Express, and we're going to get started with that in just a moment. So whether it's Simulation or Simulation Express, let's go ahead and get started with it. So I'm going to go up here to my button up here in my Evaluate toolbar. That's how I access Simulation Express. And we're going to start from the very beginning. What we want to do is we want to go to Options. So we want to choose your units. It could be English units, IPS, or it could be international units. And I'm going to stick with English just because we modeled this in English for our SolidWorks mechanism. So I'm going to go to OK. And then we're going to go to Next over here. And you could use this wizard over here to help navigate through this. So first thing you want to do is you want to make sure that you take a look at some of the different applications of this. And if you click on this, it's going to show you actually just kind of a flyout there what the different applications are. So we're going to stick with just the way the model is right now. We're going to go ahead and add a fixture. What it means is that we're going to fix a surface on our model, and then everything's going to be all the pressure or forces that we're going to apply to this surface is going to be static to it. So we're going to go ahead and click on that surface. You can see our feature manager kind of flies out over here, kind of gives us an example of what we mean by a fixture on that. So in this animation that you see in here, we're actually going to fix this surface, and that the rest of the model is going to be able to flex according to that, depending on the pressure or the forces we're going to put on that. So we have our selection box over here, which allows us to select something out here in the modeling area and the graphics area. We went in and chose that bottom, so we're going to go to the green check mark. And now we have that in place. So you'll notice that over here we have the wizard, but you also have over here, we have our feature manager for simulation or Simulation Express. So we have our fixture in place. Now we have to put a load in there. So we can right click in external loads and actually apply that over here. If we go through the wizard, what we want to do is we want to go to next. We could add more fixtures in here. If we want to make another portion of this fixed, we could do that. But what I'm trying to do here is to show you the basics. So when you actually do your simulation, you can go through a lot more of the different options in here in order to be able to demonstrate that to your class for your final design project presentation. So we're going to go to next. Now we're going to add a force. You could add a pressure, but a pressure is going to distribute that force amongst an area. But we're going to add a force in here. So we're going to go ahead and click on force. We're going to go ahead and click on this surface in here. So we're going to add a force to that pin. And we're going to push that back. So it's going to be static down here. We're going to push this thing around, and we can probably suspect that it's probably going to fail right down here where the feet are. But we don't know that yet until we actually run this. So we're going to go to the green check mark and put that in place up. And what it is, put a force of 1 foot-pound in here, and that probably is not going to work very well. So we're going to put in a 325 for that. Actually, well, let's put in 300. I think 300 will work better. So we're going to put in 300, and that's going to be foot-pounds. We can put the direction in there. We can reverse a direction if we want to do that, but we're going to stick with the direction that we have in there and go to the green check mark. So now let's go to next. Now that we have a fixture on the bottom, we have a force in place. Now we want to be able to analyze that. Before that, we want to make sure we pick our material, and we can go to next in this, or we can actually change the material if we want to do that. But we're going to stick with the material that we have in our tree in here, and we have brass in here. And if we go into edit material, you can actually see the database that actually defines this. And what we're looking at here is going to be yield strength. And right now the yield strength is in, the units. We can change the units back to English. But the yield strength here is about 35,000 pounds per square inch. And we're going to go ahead and keep that in mind as we go ahead and put our get our analysis together and take a look at the results. So we're not going to change the material. We're going to go to next. We can change our settings. We can start over. We can go back, or we can run it. So we're going to go ahead and run it. And you'll notice that it's got a dialog box that pops up there, and it's going to actually show us the results. So the first thing it's going to do is it's going to give us an animation of an exaggerated displacement that we see there. So you can actually see with that displacement, the displacement is going to be so small, it's probably about 1/16 of an inch on the top, but it exaggerates that by quite a bit. So you'd actually see it where it's going to yield or where it might bend on you. And you can see down here that this is static, as we told it it's got to be. Maybe the top isn't quite as static as the metal begins to, compress and go into tension. But you could actually see what that's doing. That's a nice little animation. You can spin that around too and look at it from the back, from the bottom, or whatever angle you want to take a look at that. So when you're done with the animation, you press Stop Animation. You can go to Yes and Continue, and it gives you some more options in here. Right now it shows us what the factor of safety is going to be, and it says it's 90%. Which means if we're going to apply that load, that 300-pound load in this, factor of safety is less than 1. Less than 1 means it's going to fail. And, the much smaller than it is from less than 1, it's probably going to fail much quicker and a little bit more dramatically than it would be. Typically what you want to do is you want to have a factor of safety of like 2, 3, or 4 in there. So just in case, the forces that are applied to this, maybe in just a momentary way, are going to exceed what our design limits are going to be. And then you want to make sure that it's still going to be within that factor of safety. So right now it shows us a factor of safety of 1. These areas that are red in here are going to be areas where it's probably going to yield or begin to break there. So this is an area where it's going to be less than a factor of safety of 1 in here. So other things we might look at is von Mises stress. You can see a little stress bar over here. Kind of gives us kind of a color-coded chart over here. Shows us what the yield strength is going to be, which is about 35,000 psi. And you can see that the yield strength is in this like darker orange area in here, and it's going to correspond to this area down here. So it's going to yield over here, which means it's going to bend. This shows us that the pressure is the highest in that area, and it's beyond yield strength. So that's what that red arrow means, which means it's probably going to fail there. So it's going to stretch, it's going to bend, and might actually break right in that area. So other items in here too. Shows the displacement. So we went from von Mises stress down to displacement. We also already saw the factor of safety. So it shows us the displacement. As we're pushing on that, we would expect that that end of that pin would actually displace quite a bit. There's actually a little bit more displacement up here because it's a little bit further away from that. But it shows you what displacement is going to be, and it's 8.0. Let's see, we have to move the decimal 2, so it's going to be 0.08 or 80 thousandths of an inch, or just a little bit more than about 1/16 of an inch of displacement if we were to put 300 pounds on that 3-inch tall part. So those are the results so far. So now we know it's going to yield. If we go back to von Mises stress, we know that our part's going to fail with the parameters we put on that. So what do? Well, you can reduce the force on it maybe, but the nice thing about SolidWorks, with the parametric design that we're putting together, we could actually put stuff in here, like maybe a fillet. As you saw earlier, we're going to put a fillet in here and see what that does to help strengthen our model. Okay, so let's take our simulation over here, our Simulation Express over here, our wizard. Let's go ahead and close that out. It's going to ask us if we want to save it, and we're going to go ahead and say yes. So we have these values in here a little bit later. Let's take our model and actually put that fillet in place. So I actually did that a little bit earlier, took it out, but now we put it back in. And let's go ahead and unsuppress that and see what we have. So we have a 20 or 0.20 or 20 thousandths of an inch fillet in that area. And let's just go back to Simulation Express and see what that does. So we're not going to start over in here, but what we can do is go over here to the Feature Manager tree for the simulation and actually do run. So let's go ahead and run that and see what we got. So we're not going to stop the animation, but we're going to continue. We're going to go to the von Mises stress, and now we can see with our factor of safety in here of 1 that it's actually going to yield down here. So this is an area where it's going to fail. And it's going to show us that in that area our factor of safety is now, what, 65%? So by putting that fillet in, it actually made things a little bit worse. But let's see our von Mises stress, and now you can see that that area has actually moved down by quite a bit. So everything is going to be in that light green area. That green-yellow area is actually going to be an area where it might fail. Everything is going to be green, yellow, and up towards red is going to fail. So it could fail in anywhere in that area. You could also look in the back too. You can actually rotate your model around and see where other stresses might be. But that area where it's red is going to be the highest stress. So it's going to be about 35,000 PSI over here. But the red area has actually got, and that's where the yield is, by the way, about 35,000. That's where the yield strength is going to be. But up here, it's like 53,000, 54,000 over here where it's going to be red. So actually the stress is actually increasing. The pressure actually increased right in that area. So let's do this. Let's again go ahead and close this out and go back to our fillet and see what we can do about that fillet and maybe make that fillet a little bit better. So typically a fillet actually reduces the stress, but sometimes it's about how you add that fillet in there and what you're going to fillet in here. So we actually created a stress area right in this area that actually caused quite a bit of stress. So if we go back to that fillet and actually fillet that around the corner, we could do that too. That might actually help. So if we do that, go to the green check mark. Go back here to Simulation Express. Let's go ahead and run it. So we're going to right click over here and go to run and see what we got out of that. Let's go ahead and turn that around a little bit. We can see our displacement or displacement animation. Go to yes and continue. So now it actually reduced itself down a little bit. You can still see a little bit of red down there. Maybe not as much as there was before. But let's go ahead and look at our von Mises stress. So it's actually way, way up there at the top. And the displacement of the red is going to be a little bit more spread out. So one thing we could do with the fillet is we could actually go and change it a little bit better, change it a little bit more, maybe make that 1/4 of an inch instead of 20% of an inch. So let's do that, maybe 0.25. Now we can see our fillet is going to be influenced by that hole that's in there, which is probably okay. Go to the green check mark, again go back to simulation. Let's go ahead and solve that again. We're going to right click on that and go to run. And in a way, what we're doing here is we're going through the iterative process of designing, testing, designing, and testing back and forth until we get something that's going to work. So now if we stop the animation, go to yes to continue, now we see no more red. So our factor of safety now is above 1. Be nice to have that a little bit higher than 1, but 300 pounds is probably a lot of force in there. It's for a 3-inch part, that's a lot of force. But and typically a factor of safety is anywhere like maybe 2, 3, 4, depending on the application in the industry. But you definitely want to have it above 1 because you're almost guaranteed the thing's going to fail if you don't do that. So if we go to the von Mises stress, now you can see our yield arrow in here is gone. Although we still have red in here. The red just shows us where the maximum stress is going to be. If we want to reduce that stress down, maybe we can make that fillet a little bit bigger. Maybe we can make the feet of our feet a little bit thicker. Perhaps a different form. Maybe put a rib in there. There's a lot we can do in there in order to reduce the stress. And if we did that, we could probably get the yield strength down by quite a bit. It's still going to be red. You're still going to see red in here. But the yield strength is going to be way off the charts, perhaps. And if we do that, we're probably going to get the factor of safety for that 300-pound load on the very end of that. We're going to get that factor of safety much above 1 if we continue to make modifications to our part. Okay, so in a nutshell, that's kind of simulation or Simulation Express. And we, again, demonstrated Simulation Express. You want to make sure you do simulation for your final design projects. But this gives you a start, kind of shows you the engineering behind SolidWorks. Simulation gives you a lot more flexibility, gives you a lot more options, and you're going to get better results too. I mean, these results are good for a really simple and basic model that we have here. But if you have something a lot more complicated, definitely use simulation. Going to be looking for that. So what else can you do with this? Gosh, if you're done reviewing or viewing the results, we could generate a report, which is really kind of fun. If we go to generate that report, It gives us the capacity to actually put our designer, which would be your name, the company name, URL, logo. You know, we click in this box and actually find the logo, and it puts it in the report. But you actually go to generate, and what it's going to do is it's going to create that Word document for you. And it's going to put that together in a pretty nifty little report. This is something you can professionally present to somebody, and would show the results of your analysis. So it's engineering taken seriously, if you might want to consider that. So let's go ahead and take a look at that Word document it just generated. It's got its table of contents. It has a lot of the elements that we talked about and demonstrated as we went through this. It shows you where the fixtures are, where the force is. It talks about a little bit more parameters in regard to the model, material properties. It shows you where it's fixed with a little bit more detail, where the force was. It talks about the mesh information. We didn't really talk about the mesh at all, but this is what the mesh actually looks like. With simulation, you get a lot more options with the mesh. You don't have the capacity in Simulation Express to be able to change the mesh. But typically, a more dense mesh is going to give you better results, especially if they have areas that have a high concentration of what looks like a high concentration of pressure, of stress. So we have the capacity to actually, take that mesh and actually, modify that a little bit, make it less dense or more dense. Then it kind of gives you the results of your report. So it talks about, the stress that we had, the displacement, and then, another one about displacement here too. And then some other elements in here too that you might find useful. So it puts together a really, really nice report. Gives you the capacity, of course, in a Word document to continue to add to that if you want to do that. So that's Simulation and Simulation Express as an introduction to the engineering portion of SolidWorks. So have fun with that, and good luck with your model.